So today we will continue this 12th class chemistry, 12th chemistry continuation. This will be lecture number 02. Okay, we have started the unit number 10, haloalkanes and haloarenes, haloalkanes and haloarenes. Okay, we'll continue. As I told you, I'll provide you all the notes and the basic concepts regarding this, so you can jot it down. So it will be beneficial for you and make your tuition free life. Okay, do prepare in your home for your upcoming examination that will be on February month. So to prepare for that February month board examination. So let us start this. We have completed till benzylic halides. Hope you have revised all those things. Okay, now next will be your vinylic, and vinylic will be like the classification we have done. That will be like sp3 carbon, sp3 carbon attached with halogen. That three classification we have done. That is haloalkane, then your allylic, and then your benzylic. These three we have completed. Correct? These three we have completed. Now today we are going to discuss for this sp2 carbon connected with the halogen, and here also we have two type. One will be your vinylic halide and another will be your aryl. Okay, aryl halide. This is also halide. Here also we can write halide. So these two we are discussing over here, and after that we'll continue again. I'll give you the notes and the concept. So first we will start with the vinylic halide, and we know that vinylic halide, it is the halogen will directly connected to the sp2 carbon. Okay, so we'll write something like we have to write something for academic examination, so that concept we will write over here. Here the here the halogen atom is bonded. Okay, and the halogen atom is bonded to a sp2 hybridized carbon atom of a carbon-carbon double bond. Got it? Of a carbon-carbon double bond, that you have to make sure. Okay, it is the difference between allylic and vinylic. See, allylic we have next to the double bond the sp3 carbon atom where the halogen is attached, right? But vinylic, in the same double bond you have to attach it. Suppose this is CH2. Now this will be CH and one halogen you are attaching to this carbon only. And what is the hybridization of this carbon? The hybridization of this carbon is sp2. And what is the hybridization of this carbon? This is also sp2. So it means either you are adding in this position or you are adding in this position, both will be the vinylic position. Okay, if we are talking about vinylic position, so vinylic position, your vinylic position will be either this position or this position. Both the position are vinylic only over here. Correct? Now for the cyclohexene, the same example I will take which I have taken for your allylic also. So in that, these two position will be your vinylic position. Got it? These two position is your vinylic position. This one and this one. Correct? So if you are adding one halogen over here, it will be vinylic halide. Okay? Now, okay, in this, what all are present, what all position we can name it, just see. For this cyclohexene, okay, I'll just change the color. I'll take some other color. This color I'll take. This is your vinylic. This is also vinylic because these two are sp2. This is sp3. So this will be your allylic. This one will also allylic because this is next to double bond. Here this carbon is also next to double bond and it is sp3. Here also it is sp3. Now one more name is there next to allylic position. If it is sp3, we call it homoallylic position. Okay, just next to allylic position. Likewise, here also next to allylic position is your homoallylic position. Got it? So all the 6 position we can name it for this particular compound. Okay, so these two are sp2 sp2, so these two will be vinylic. This will be allylic because next to double bond, and next to allylic carbon we call homoallylic position. Here also the next to the allylic carbon we call it homoallylic position, but this is not required for your 12th standard. But sure, if you are preparing for NEET, okay, if you are preparing for NEET, UG, or maybe JEE Main, it is required. Okay, it is required. They may ask you what is the position name, correct? So that's why I thought I'll just include over here. Okay, okay. So next will be your aryl halide. Okay, next will be your aryl halide. Next will be your aryl halide. So here also we will write some concept, then we will start it. Okay, here the halogen atom directly attached to the sp2 hybridized carbon atom of an aromatic ring. Got it? Here the halogen atom is directly attached to the sp2 hybridized carbon atom of an aromatic ring. So here also the halogen is attached to the sp2 hybridized carbon atom. In vinylic also it is attached in sp2 hybridized carbon atom. But what is the difference? There the conjugation is not. See, in this case there is no conjugation. No conjugation, okay? It is localized. This pi electron is localized. So we call it vinylic position. But now what is the case over here? This is the aryl or benzene, we say benzene, and if we are attaching halogen over here, this is aryl halide. Okay, here also this carbon is sp2, but here the conjugation is there, right? This can shift over here, this can shift over here, this can shift over here. The conjugation is there. Okay, so that's why the difference is vinylic and aryl. This one the difference is, okay, here the conjugation resonance is present over, or we can say directly it is directly attached to the benzene ring. Okay, benzene's sp2 carbon. Okay, so by this classification is over. Next nomenclature we'll see it. Okay, nomenclature. So suppose this is the compound, and maybe in 11th class you have completed this topic. Okay, here we'll see the IUPAC name. You can say easily 1, 2, 3. So 2-chloropropane. But what is the common name for this? This is your isopropyl chloride. So again you are going to mug it up, or some basic concepts is there for this name. Why this name came? Just let us discuss. This is iso, right? Iso means same. Now you just see, I'm just putting a line over here along with this chlorine, or we can write it like this. This is carbon, this is CS3, this is CS3, this is hydrogen, and here I can write chlorine. Here also we can pass a line over here. Now you just see right hand side and left hand side. Here also you can see right hand side of this plane and left hand side of this plane, both are same or not? This one and this one is same. Here also this one and this one is same. Hydrogen and chlorine along with this plane is going. So these two are same. So we can say same, and this is a propyl chloride. Okay, so same propyl chloride. It means isopropyl chloride. So no need to remember that this is isopropyl chloride, or maybe if suppose I am adding over here CH3, CH2, and then CH2Cl. If we are adding like this, what is name? It is N. Small letter N is nothing but normal. Okay, there is no iso, there is no branch. So we will write simply N. So this will be N propyl chloride. Got it? This is N propyl chloride, normal propyl chloride. or in IUPAC you will write 1 chloropropane. Okay, because position will start from here only, 1 chloropropane. For this also it will be like 1, 2, 3. So it will be 2 chloropropane. But they will ask you the common name, isopropyl chloride. And believe me, they are not going to ask you why isopropyl chloride we call it. Okay, they are not going to ask you. But to make you understand, because otherwise what will happen, you will start mugging up the things, right? This is isopropyl. So to take out, because chemistry means you have to understand very well. There is in entire chemistry, we don't have any single concept which we have to memorize it. Okay, there is nothing to memorize in chemistry, so everything is understandable. Whatever name it's given, whatever concept it is there, it can be understandable. Okay, so that you have to understand. See why it is iso, it means one plane is passing, both the sides same group is coming, so this is same propyl, it means isopropyl chloride. Got it? So we are using the Latin word, that's why these names are coming. Now correct. Now suppose this one, I'll just rearrange and write the compound. Okay, so this is CH3, again coming to this carbon, then it is CH3. Okay, and what I'll do, I'll just one hydrogen I'll put it over, and I'll write over here CH2, and then I'll write chlorine. Now you just see 1, 2, 3, 4. So 4 means it will be butane. Okay, and again you see I can pass a plane over here, so we call it isobutyl chloride. Got it? Isobutyl chloride. This is isobutyl. Again, the same group are coming over here, both the sides. Or this in general way, how it is written in your book, that way also we can write it CH2, sorry, CH3, then it will be carbon. Here one CH3 you put it, here another CH3. Okay, 1, 2, 3, and 4. So this side it won't be there. Here hydrogen will be there, hydrogen, and then you put CH2Cl. So this way also we can write it. So what you have to do, you have to just rearrange and arrange like this and see whether any plane is passing and similar groups are present over both the side. If it is like that, then we call it isobutyl chloride. This is isobutyl chloride. This is isopropyl chloride. Okay, like that we have tertiary butyl also. Okay, this is carbon, CH3, 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 and chloride. Why this is tertiary? It means previously also I have discussed the carbon which has attached with this halogen. This carbon is also attached with 3 alpha carbon. This we call alpha carbon. Alpha, alpha, alpha. Directly attached to this carbon, that carbon we call it alpha carbon. So 1, 2, 3, 3 alpha carbon. So we call it tertiary. Okay, 3 alpha carbon. So we call it tertiary. So this will be your tertiary, okay, butyl chloride. Okay, so tertiary butyl chloride, this is 3 degree. Okay, now one more is there that we call neo, CH3, then CH2 and chloride. So this will be your neo. Neo is a Latin word. Okay, so the carbon, okay, which is attached with this halogen, that carbon is attached with the alpha carbon which is having no hydrogen. Okay, no hydrogen, or we can say that 3 beta carbon. This is beta carbon. 3 beta carbon is attached. The carbon, okay, the halogen is attached to that carbon, and the carbon is attached with the next carbon, which is, this is alpha, this is beta. Okay, this is not beta. Beta will be your this one. This will be your beta carbon. Okay, I'm sorry. This is the functional group attached. So this will be alpha, and this will be beta, this will be beta, this will be beta. So this alpha carbon is having 3 beta carbon. So we call it new pentyl chloride. Why the pentyl will come? 1, 2, 3, 4, 5. 5 carbon are there, so pentyl. But IUPAC name is very easy for this also, even for this also. For this, what will be the IUPAC name? 1, 2, 3. So it will be 2 chloro 2 methyl propane. Here, what will be the name? 1, 2, 3. Here it will be your 1 chloro 2, 2 dimethyl and propane. Okay, 1 chloro 2, 2 dimethyl propane. So these are the IUPAC name that will be very much Easy. Okay. And even for haloarene also, if you are writing the name, if you are adding here chloro, so it will be chlorobenzene. Okay. Now if you are adding here one chlorine, suppose here one chlorine, another chlorine is there. We know that if IUPAC convention we are writing, it will be like position 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So we can write 1, 3, 5 trichlorobenzene. That will be the IUPAC. Or we can write meta, okay, meta trichlorobenzene. Meta trichlorobenzene, because meta position both the chlorine is there. So chloro. So three chlorine are there. So meta trichlorobenzene, another name. Okay, one more name is there. We can directly write sim. Sim is symmetrical. Okay, sim tribromo benzene. This name they are going to ask you. Why is sim symmetric? See, again you see one plane if we are passing either through this way or through this way. See, these two are reflecting. If we are passing through this, these two will be reflect. So this one is reflecting with this. Here this carbon is reflecting with this. This carbon is reflecting with this. So along this plane, both sides are same. So it is symmetrical molecule. So that's why the name came symmetrical tribromobenzene. Okay. So this is symmetrical. So symmetrical tribromobenzene. One more thing I want to like ortho para. I know you can tell me what is ortho, what is para, what is meta. Okay. So you will say this is your ortho position, right? Let me write and then I'll clarify you. You will say this is your meta position. Because why I'm saying maximum of my students they used to tell me in initial classes. When I used to start taking classes, if I'll ask, they will say this is ortho position, this is meta position, this is para position, again this is meta position, again this is ortho position. They used to say it, but I say it is wrong. Okay, I'll just cross it because these are not the position. This is not the ortho position, this is not the meta position, this is not the para position, this is not the meta position, and this is also not the ortho position. Okay, these are not the position. How you are going to define it? So for that, see, ortho, meta, para will come only if any functional group is attached. I'll just write functional group FG. If functional group is there, then the second position we call it ortho. If functional group is present over here, then second position. See, if you are telling ortho this, where is the source? Like from where you are starting, which position is one? If you say this is one, I'll say not. No, this is not one. I'll say this is one. Again, someone else will come. No, I will not consider this is one. I'll consider this is one. So see, there are no references. So any point can be one. And if there is no functional group, you can't say that, okay, you are correct or I am wrong or I am correct, you are wrong. You can't say this, okay? Because there is no position defined. But here now see, position is defined with this functional group. So this will be always position 1. So the next position, second position will be ortho. Third position will be meta. Fourth position will be para. This position again it will be meta. This position again it will be ortho. Now what is the position name for this? This is also having one name that we call it. What we call it? Slowly I'll write. Let me see. You can tell it or not. I P S O. We call it ipso position. Okay. So in capital we should not write, only to let me see whether you know or not. That's why I've written it's a ipso position. Okay. This is ipso position, ortho position, meta position, para position, meta position, ortho position. When the functional group is attached. If functional group is not attached, neither it is ortho, neither meta, para, meta, and ortho or ipso. Nothing is there. Okay. It will be simply benzene. So this is based like the reference of functional group. The functional group is directly attached to the benzene ring. That will be always your ipso. Suppose now functional group is attached over here. Everything will get changed. Suppose functional group is attached over here. Anything, chloro, bromo, iodo, nitro, methyl, OH, anything is attached over here. So your ipso position will be this. This will be your ortho. This will be your meta. This will be your para. Again, this will be your meta and this will be your ortho. Got it? Correct? Right. So one more point is there in nomenclature that I'll clarify you, and then we'll move further. See, one this point you just write it down. The dihalo, okay, the dihaloalkanes having the type of halogen, same type of halogen atoms, okay, are named as alkylidine and alkyli, okay, alkaline dihalide. So alkylidine dihalide or alkaline dihalide we have to name. Okay. So how? So this is your dihaloalkanes. Okay. This is your dihaloalkanes. Let me classify with the two. Okay. First will be your this type of compound CH3 single bond CH, and both the chlorine is attached over the same carbon. So we call it geminal halide. Okay, we call it geminal halide. Geminal means from the same carbon, if both the halogen is coming out, we call it geminal. If suppose with two different carbon, if it is coming over here, here one halogen and here another halogen, we call it vicinal halide. Okay, vicinal halide. Got it? Correct? It is geminal halide. This is vicinal. Vicinal means it will be next carbon. Okay, next carbon. It is not like that one carbon you have skipped and the next carbon, one and third carbon you are adding. No, one and two carbon. It will be always 1 2 carbon, 2 3 carbon, 3 4 carbon, 5 6 carbon. Means adjacent carbon the halogen should be having. So we call it vicinal. At the same carbon, if both the halogen is present, we call it geminal halide. Correct? So short form will be your gem dihalide. Here the short form will be vicinal dihalide. This you keep it in your mind. This type of question they may ask you. Correct? Got it? This is we know with the another name also. This is only your ethylidene. Okay, ethylidene chloride. This is only your ethylidene chloride, and this name will be your ethylene dichloride. Okay, ethylidene chloride, and this is ethylene dichloride. Okay, alkaline and alkylidene. Alkylidene means geminal. Alkaline means vicinal. Got it? It's vicinal and this is geminal. So by this nomenclature is completed. What will be the covering in the next class? We'll discuss over here. We'll cover the nature of CX bond. Okay, we'll cover it. Nature of CX bond. Correct. This will be covering by next class, and then we'll go for method of preparation. Method of preparation. Okay, of haloalkane, and then we'll go for haloarenes. Got it? Understood? And if required, I'll tell you how to practice periodic table. Okay, or you, if you know, do practice. It will require in this type of reactions. Okay, how do we practice periodic table? That is, you should know very well, because this periodic table will help you out for all type of reactions. Okay, this CX bond, CX means carbon and halogen. So we know that there is an electronegativity difference. So who will going to tell you the which one is having more electronegative and which one is less electronegative? That your periodic table is going to tell you. Okay, so what type of reaction it will have, so it will tell you by your periodic table. Correct? So for today, this much only. Thank you for watching.